Picture a vast, enigmatic body of water nestled in the heart of northern Europe, a sea that stretches across the landscape like a living, breathing entity, its surface often shrouded in morning mist, and its boundaries defined by the embrace of ancient land masses. The Baltic Sea is not merely a geographical feature, it is a dynamic system, shaped by millennia of geological upheaval and climatic shifts. Spanning over 400,000 square kilometers, the Baltic Sea is one of the world's largest brackish water bodies, its surface a shifting mosaic of blues and greens, reflecting the ever-changing sky above. 9 nations share its shores, each coastline sculpted by glacial retreat and the slow rise of land from the sea. From the rocky archipelagos of Sweden and Finland to the sandy spits of Poland and the low-lying lagoons of Germany, the Baltic's perimeter is a living record of Earth's ancient past. Unlike the open ocean, the Baltic is connected to the North Sea only by a series of narrow, shallow straits in Denmark. These natural gateways act as both lifelines and barriers, controlling the slow, rhythmic exchange of salt water and shaping the sea's unique chemistry. The semi-enclosed nature of the Baltic creates a world apart, where water lingers for decades before finally escaping to the ocean, and where every drop tells a story of its journey through rivers, lakes, and wetlands. The Baltic's resilience is legendary, yet its fragility is ever-present. Storms can sweep across its surface in hours, transforming tranquil bays into churning cauldrons, while delicate aquatic plants cling to life in the shifting shallows. Even the air here is different, less salty, tinged with the scent of pine and earth, a testament to the sea's diluted nature. The waves, shaped by the contours of the land, often move with a quiet persistence, their rhythm echoing the slow pulse of the region's seasons. The Baltic is a vast mixing zone, where the fresh waters of more than 200 rivers blend with the saline inflows from the North Sea, creating a brackish environment unlike any other on Earth. These rivers carry not only water, but also nutrients, sediments, and the memory of distant forests and farmlands, shaping the Baltic's character with every season. The result is a world of extremes, salinity levels that fluctuate dramatically, oxygen that can vanish from the depths, and a constant challenge for every organism that calls these waters home. Only the most adaptable species survive here, creatures that have evolved to thrive in a world where the rules of the ocean and the rules of the river collide. This complexity has made the Baltic Sea a living laboratory for scientists who probe its depths with advanced technology, seeking to unravel the mysteries of its ever-changing environment. The history of the Baltic is etched in the layers of its seabed, each stratum a chapter in the story of ice ages, human settlement, and environmental change. Life here is a delicate web, from the invisible plankton that bloom in spring to the apex predators that patrol the deeper waters, each link in the chain finely tuned to the sea's unique rhythms. To truly understand the Baltic is to appreciate the seamless connections between land, water, and life, where forests filter rain, wetlands buffer storms, and every ecosystem is interdependent. Beneath its tranquil surface, the Baltic hides dangers, zones where oxygen vanishes, where life struggles against invisible threats, and where the balance can tip in an instant. On the surface, the Baltic dazzles with its archipelagos, its endless beaches, and its towering cliffs, each a testament to the forces that have shaped this region for thousands of years. But beneath, a hidden world of stratified water layers and shifting currents determines where life can flourish and where it cannot, creating invisible boundaries that few creatures can cross. In the depths, vast stretches of seafloor lie barren, starved of oxygen, while the shallows burst with life, an ever-present reminder of the sea's contrasts. The Baltic is a sea of paradoxes, its untouched beauty standing side by side with the scars of pollution, its rich biodiversity threatened by the legacy of human activity. In every ripple, every current, and every silent depth, The Baltic Sea tells a story of resilience, complexity, and the urgent need to understand and protect one of the planet's most extraordinary marine environments. Imagine a world where the water is neither truly fresh nor fully salty, a place suspended between two extremes. This is the brackish water realm of the Baltic Sea, a unique aquatic environment shaped by a delicate balance of forces. Brackish water is, in essence, a natural blend, like a drink diluted with just enough water to blur the line between fresh and salty. But here, the recipe is written by rivers and tides, not by human hands. In the vast open oceans, salt concentrations reach about 35 parts per thousand, creating an environment where only true marine life can thrive. But the Baltic Sea is different. Here, the surface salinity can drop as low as 3 to 9 parts per thousand, a fraction of the ocean's saltiness and a testament to the sea's extraordinary geography. Over 250 rivers pour their freshwater into the Baltic, each one diluting the sea's salt and reshaping its chemistry. These rivers are the lifeblood of the region, carrying nutrients, sediments, and the memory of distant landscapes. As this lighter, fresh water enters, it forms a distinct layer above the denser, saltier water that seeps in from the North Sea. The result is a striking vertical stratification, a natural layering that defines the Baltic's underwater world. This stratification is not just a visual phenomenon, it's a physical barrier, separating the upper and lower layers and preventing them from mixing. The boundary between these layers is called the halocline, a sharp transition where salinity changes abruptly. The halocline is a defining feature of the Baltic, a shimmering underwater frontier that shapes the lives of every organism in these waters. For the creatures that inhabit the Baltic, this layered world is both a challenge and an opportunity. Each species must find its place within the shifting boundaries of salinity and temperature. Plants and animals here face a constant physiological puzzle: how to maintain the delicate balance of salt and water within their cells when the environment around them is in perpetual flux. The secret lies in osmoregulation, the ability to control internal salt concentrations. In the Baltic, this process is pushed to its limits, demanding extraordinary adaptations at the cellular level. Most marine species are finely tuned to the high salinity of the open ocean, while freshwater species are adapted to environments with almost no salt at all. The Baltic, however, is neither one nor the other. Geographically and chemically, the Baltic Sea is a crossroads, a meeting point between the salty Atlantic and the vast freshwater catchments of northern Europe. Only a select group of species, true brackish water specialists, have evolved to survive in this in-between world. Many are found nowhere else on Earth. These organisms must expend significant energy just to maintain their internal balance, leaving less for growth and reproduction. Every heartbeat, every breath, is a testament to their resilience. At the microscopic level, their cells are equipped with specialized pumps and channels, working tirelessly to move ions in and out, counteracting the relentless pressure of the surrounding water. This demanding environment means that biodiversity is limited. The Baltic supports far fewer species than neighboring seas, and each one plays a critical role in the ecosystem. In contrast to the North Sea's vibrant tapestry of life, the Baltic's food web is sparse, its connections fragile. Here, you won't find the lush coral reefs or towering kelp forests that define other marine environments. Instead, the seafloor is often barren, shaped by centuries of shifting salinity and oxygen levels. Yet, the species that endure are among the toughest on the planet. Their survival strategies are as varied as they are ingenious, from anti-freeze proteins to unique reproductive cycles timed to the Baltic's changing seasons. Many Baltic species are smaller than their oceanic relatives, a direct result of the energy they must devote to osmoregulation. This size difference is a subtle but telling adaptation to the brackish world. The Baltic's food web is a delicate architecture where a handful of key species like herring, cod and sprat support the entire ecosystem. The loss of even one can send ripples throughout the sea. The chemistry of the Baltic is in constant flux, influenced by seasonal changes, river inflows and the slow pulse of salt water from the North Sea. This dynamic system is a living laboratory for scientists studying the boundaries of life. The strong stratification acts as a barrier, trapping oxygen in the upper layers and leaving the deep waters starved. This separation creates vast hidden regions where life struggles to gain a foothold. These oxygen-deprived dead zones are among the largest on the planet, a stark reminder of the Baltic's vulnerability and the intricate interplay between water chemistry and life. Yet this stratification also creates a mosaic of habitats, each with its own community of organisms adapted to the precise conditions of depth, light and salinity. In the sunlit surface waters, life flourishes. Algae bloom in the nutrient-rich light, forming the foundation of the food web, while fish dart and feed in the shifting currents. But descend past the halocline and the world changes. The water grows darker, saltier, and increasingly hostile. Here, in the silent depths, only the most specialized life forms persist, clinging to existence in a realm where oxygen is scarce and survival is a daily battle. The Baltic Sea, with its serene blue expanse, conceals a crisis unfolding beneath the waves, a crisis invisible to the casual observer, yet devastating in its reach. Hidden below, vast stretches of the seafloor have transformed into what scientists call dead zones, underwater deserts, where life is all but extinguished. In these dead zones, oxygen levels plummet to such extremes that nearly all marine animals, fish, crustaceans, even the resilient polychaete worms, are unable to survive. The seafloor becomes a graveyard, stripped of its vibrant biodiversity. For marine creatures, the experience is akin to being trapped in a sealed room with the air slowly vanishing. Fish and invertebrates, desperate for oxygen, are forced to flee or perish, leaving behind a silent, empty world. Over the past 100 years, the scale of these dead zones has exploded. Once limited to small pockets, they now cover an astonishing 70,000 square kilometers, an area surpassing the size of Lithuania. This expansion is not random. It follows a clear scientific pattern driven by human activity and natural processes. The result is a vast, lifeless expanse stretching across the Baltic's depths, a silent transformation that is fundamentally reshaping the region's marine ecosystem. The primary engine behind this transformation is eutrophication, a process triggered by an overabundance of nutrients, particularly nitrogen and phosphorus, entering the sea. These nutrients, originating from agricultural fertilizers, urban wastewater, and industrial discharges, act as a potent fertilizer for microscopic algae. Rainfall and river systems carry these chemicals from fields, cities, and factories, funneling them into the Baltic from every corner of its vast watershed. The sudden influx of nutrients sparks explosive blooms of algae and phytoplankton, turning the sea's surface into a dense green mat. For a brief period, the water becomes a thick, soupy mass, clouded with microscopic life. But this abundance is short-lived. As the algae die, their remains drift downward, blanketing the seafloor in organic debris. Bacteria swarm to decompose this material, consuming vast quantities of oxygen in the process. This microbial feast rapidly depletes the available oxygen in the deep water. The Baltic's unique structure compounds the problem. The sea is layered with lighter fresh water floating above denser, saltier water. This stratification acts as a barrier, preventing oxygen from the surface from reaching the depths. As a result, the oxygen consumed by bacteria at the bottom is not replenished, and the deep water becomes increasingly starved of life-sustaining gas. This stratification is so persistent that in some regions the deep water has remained isolated for decades, cut off from the vital exchange with the surface. Over time, the oxygen concentration drops to zero, a condition known as anoxia. In these black, suffocating depths, almost nothing can survive. In the most extreme cases, the water becomes euxinic, saturated with hydrogen sulfide, a toxic gas that not only smells of rotten eggs, but is lethal to most forms of life. Only specialized bacteria, adapted to thrive without oxygen and capable of metabolizing sulfur compounds, can persist in these hostile conditions. These microbial communities form strange, pale mats across the seafloor, a stark contrast to the once diverse marine life. Occasionally, nature intervenes. Powerful storms and rare weather patterns can force salty, oxygen-rich water from the North Sea into the Baltic's deep basins, a phenomenon known as a major Baltic inflow. These inflows, such as the significant event in December 2023, act like a giant ventilator, flushing out stagnant anoxic water and temporarily restoring oxygen to the depths. For a brief window, life can return to the deep, and some fish and invertebrates recolonize the seafloor. However, these events are infrequent and cannot keep pace with the relentless input of nutrients. The ongoing influx of nutrients from agriculture and urban sources continues unabated, overwhelming the Baltic's natural ability to recover. The dead zones persist and expand, suffocating the sea from below. In the Gulf of Finland, for example, entire stretches of sea floor have lost their benthic communities, and cod, once a dominant predator, have vanished from these areas. The silent spread of dead zones is not just a scientific phenomenon, it is a profound ecological upheaval threatening the very fabric of the Baltic's underwater world. In the Baltic Sea, survival is a test of ingenuity and resilience. Here the water is neither truly fresh nor fully salty, a brackish blend that challenges every living thing to adapt or perish. Only the most specialized creatures can carve out a niche in this ever-shifting environment. Many of the Baltic's inhabitants are not simply visitors from the Atlantic, but distinct ecotypes, populations that have diverged from their oceanic relatives, evolving unique physiological and behavioral traits to master the Baltic's demanding conditions. Consider the Baltic herring, a smaller, more compact cousin of the Atlantic herring. Over generations, it has become perfectly attuned to the sea's diluted salinity and fluctuating temperatures. This unassuming fish is the linchpin of the Baltic food web, sustaining a host of predators from seabirds to larger fish. Its abundance and adaptability make it a keystone species, vital to the ecosystem's balance. To survive in water with such low salt content, the Baltic herring has developed highly specialized gill cells and kidneys. These organs work in concert, constantly regulating the delicate balance of salts and fluids, allowing the fish to thrive where others would falter. The Baltic flounder is another marvel of adaptation. Its flat, camouflaged body blends seamlessly with the sandy seabed, a perfect defense against predators in the dim, sediment-laden waters. Unlike its oceanic cousin, the European flounder, which releases buoyant eggs that float in the salty Atlantic, the Baltic flounder faces a different challenge. In the Baltic's less saline waters, eggs that would normally float instead sink, risking descent into the dark, oxygen-starved depths where survival is impossible. The Baltic flounder has solved this problem with remarkable precision. It lays its eggs directly on the seafloor, but only in select regions where the salinity is just right, between 5 and 7 parts per thousand, ensuring the eggs remain in a safe, oxygen-rich layer. These microhabitats are rare and scattered, making the search for suitable spawning grounds a matter of life and death. The flounder's entire reproductive strategy is a testament to the razor-thin margins for survival in the Baltic. The eastern Baltic cod, a top predator, faces its own set of challenges. Its journey is one of both remarkable adaptation and ongoing struggle. Over time, the cod has developed genetic modifications that help it retain precious salt and maintain water balance, allowing it to function in the Baltic's diluted environment. Cod eggs are especially sensitive, requiring a narrow band of water with a salinity of about 14.5 parts per thousand, to remain suspended. This keeps them safely above the suffocating, oxygen-depleted dead zones that lurk below. Yet the cod's resilience is being tested. Decades of intense fishing pressure have dramatically reduced their numbers, leaving the population vulnerable and fragmented. In response, cod are now maturing at younger ages and smaller sizes, a rapid evolutionary shift that signals the ecosystem's mounting stress and the species' desperate bid for survival. Even the tiniest inhabitants, like zooplankton and small crustaceans, have developed unique ways to endure. Some produce resistant eggs that can survive in low-oxygen mud, hatching only when conditions improve. Among the Baltic's most extraordinary residents is the viviparous eel pout. Unlike any other fish in these waters, it gives birth to live young, bypassing the vulnerable egg stage entirely. This adaptation shields its offspring from the dangers of drifting in the unpredictable water column, giving them a head start in the race for survival. The eelpout's resilience extends to the harshest months. While most fish slow down in the icy grip of winter, the eelpout remains active, foraging beneath the frozen surface, undeterred by the cold. Each of these species, from the herring's salt-regulating organs to the flounder's pinpoint spawning, the cod's genetic resilience, and the eelpout's live birth, reveals a tapestry of survival strategies. In the Baltic Sea, life is a constant negotiation with adversity, a living laboratory where evolution's creativity is on full display, and only the most adaptable endure. In the intricate tapestry of the Baltic Sea, a select group of predators reign supreme, their presence shaping the very structure and rhythm of life beneath and above the waves. These top hunters are not merely survivors, they are the architects of balance, their every move echoing through the ecosystem. The grey seal stands as the undisputed apex predator of these waters. With a streamlined body built for both power and agility, the grey seal glides effortlessly through the chilly Baltic currents, its keen senses attuned to the faintest flicker of movement. Decades ago, these remarkable marine mammals teetered on the brink of extinction, their numbers decimated by relentless hunting and the insidious effects of pollution. By the 1970s, only a few thousand remained, their future uncertain. Yet through dedicated conservation and the gradual healing of the sea, the grey seal population has surged back, now numbering over 55,000. Their return has restored a vital force to the Baltic's food web. Grey seals are relentless hunters, capable of plunging to depths of 70 meters in pursuit of their prey. Their diet is dominated by swift, silvery fish such as herring and sprat, which they track with acute underwater vision and a powerful sense of smell. In recent years, a dramatic shift in their behavior has been observed. Grey seals have begun preying on the much smaller harbour porpoises, demonstrating a remarkable adaptability and a fierce dominance. These encounters are swift and decisive, underscoring the seal's role as a true top predator. Above the water, the great cormorant commands the skies and the shallows. With wings outstretched, it surveys the sea, its sharp eyes scanning for the glint of fish below. The cormorant is a master of the hunt, plunging beneath the surface with astonishing speed and precision. It can dive to depths of nearly 10 meters, propelling itself with powerful webbed feet, and snatch fish in a sudden practiced strike. Once nearly lost to the region, the cormorant's resurgence has restored a vital link in the Baltic's food chain. Their colonies, now numbering tens of thousands of breeding pairs, are a testament to nature's resilience. As they hunt, cormorants exert a powerful influence on fish populations, ensuring that no single species dominates. Their predatory pressure helps maintain a delicate equilibrium, preventing imbalances that could ripple through the ecosystem. High above, the white-tailed eagle soars with effortless grace, its massive wings casting shadows over the land and sea. This is Europe's largest eagle, a sentinel of the Baltic's wild places. With a wingspan reaching nearly 2.5 meters, The white-tailed eagle is both hunter and scavenger. Its keen eyesight allows it to spot prey from great heights, while its powerful talons deliver swift, lethal strikes. The eagle's diet is as varied as its hunting methods. It plucks fish from the water's surface, ambushes water birds, and scavenges on the remains of other animals, recycling nutrients back into the ecosystem and keeping the shoreline clean. The white-tailed eagle's story is one of both tragedy and hope. Once driven to the edge by hunting and toxic pesticides, their nest stood empty for decades, a silent warning of the dangers of human interference. But with the banning of harmful chemicals and renewed protection, the eagles have returned, their haunting calls echoing once more across the Baltic's wild coasts, a living symbol of recovery and resilience. Not all of the Baltic's top hunters are creatures of the open sea or sky. In the shadowy shallows and river mouths, the Northern Pike lurks, a freshwater giant perfectly adapted to the brackish borderlands. The pike is a master of stealth, gliding silently among the reeds where fresh and salt water mingle. Its long, muscular body and razor-sharp teeth make it a formidable ambush predator. Growing up to 1.5 meters in length, the pike waits motionless, perfectly camouflaged, until the moment is right. Then, in a sudden burst of speed, it lunges at unsuspecting fish, frogs, or even small birds and mammals that venture too close. Its varied diet and adaptability allow the pike to thrive where other predators cannot, making it a crucial link between the riverine and marine worlds. Together, these hunters, seal, cormorant, eagle, and pike, form a living network that binds the Baltic's diverse habitats. Their interactions with prey and with each other maintain the delicate balance of this unique sea, ensuring that life in the Baltic continues to thrive in all its complexity and wonder. Beyond the iconic top predators, the Baltic Sea is a living mosaic, home to a remarkable supporting cast of animals, each uniquely adapted to this brackish, ever-changing world, and each playing a vital role in the ecosystem's delicate balance. The harbour seal, a smaller and more elusive cousin of the grey seal, survives in a small, isolated population around the Kalmar Strait, between the Swedish mainland and the island of Öland. These seals are masters of stealth, often seen only as fleeting shadows slipping into the water. In the 1970s, this population teetered on the edge of extinction, with just 10 breeding females remaining. Their survival was a testament to resilience in the face of pollution, hunting, and habitat loss. Thanks to decades of dedicated protection, their numbers have slowly rebounded, reaching nearly 600 by 2008. Yet their future remains uncertain, as small populations are acutely sensitive to disease and environmental change. Their struggle is a stark reminder of the fragility of isolated populations in a sea that is constantly shifting. Another elusive resident is the harbour porpoise, the Baltic's only native cetacean. This small, shy whale is a master of silence, rarely seen, but vital to the ecosystem as both predator and prey. Critically endangered, the Baltic population is estimated at fewer than 500 individuals. Each one is precious, a living link to the sea's ancient past. These porpoises face a gauntlet of threats: entanglement in fishing nets, relentless underwater noise from shipping, and the ever-present risk of pollution. Noise pollution, in particular, disrupts their echolocation, making it harder to find food and avoid danger. Recent discoveries reveal that the growing grey seal population now preys on porpoises, adding a new and unexpected challenge to their survival. In this intricate web, every porpoise counts. In the far north, the Baltic ringed seal reigns, a creature exquisitely adapted to life on the shifting sea ice. This rare subspecies is a living relic of the last ice age, perfectly suited to the cold. The ringed seal's entire life revolves around the winter ice. Without it, they cannot breed or raise their young, making them a sentinel species for the health of the northern Baltic. Mothers carve out snow layers on the ice, sheltering their pups from the bitter cold and from aerial predators like white-tailed eagles who patrol the frozen expanse in search of vulnerable young. Once hunted to the brink, the ringed seal population has rebounded to around 25,000. Their presence is a sign of hope, but also a warning. Climate change now threatens their icy world. As winters grow warmer and the ice season shortens, these seals are running out of safe places to give birth and rear their young. The future of the ringed seal and the entire northern Baltic ecosystem hangs in the balance as the ice retreats. The Baltic skies and shores are alive with birds, from the familiar to the rare. Caspian terns with their striking red bills and black guillemots dressed in velvet black nest alongside more common species, each contributing to the region's biodiversity. The Baltic's thousands of islands and islets are vital breeding and feeding grounds for countless species, including the rare razorbill and the elegant red-necked grebe. These birds are not just residents, they are travelers, linking the Baltic to distant lands through epic migrations. The common eider, a large sea duck, forms dense colonies on the outer archipelagos, relying on the sea's bounty of mussels and crustaceans. Alongside them, long-tailed ducks and smews dive for food, each species a specialist in its niche. Terns and gulls fill the air with their calls, diving for small fish in the shallows. The little tern, one of Europe's rarest seabirds, finds sanctuary here, while black-headed gulls squabble over scraps along the shore. These bird communities are the pulse of the Baltic ecosystem, transferring nutrients between sea and land and serving as living indicators of the health and abundance of life beneath the waves. Even the rare oyster catcher and avocet, with their specialized feeding habits, play a crucial role in maintaining the balance of this extraordinary sea. Hidden beneath the surface, the ancient European sturgeon, once abundant, now critically endangered, still haunts the Baltic's river mouths. As a keystone species, its presence shapes the food web, and its recovery would signal a healthier, more resilient sea. Even the smallest creatures matter. The viviparous blenny, pipefish, and the rare four-horned sculpin thrive in the Baltic's unique mix of salt and fresh water, providing food for larger animals and helping to keep the ecosystem in balance. In summer, blooms of moon jellyfish and the delicate comb jelly drift through the green waters, their presence a sign of changing conditions and a reminder of the sea's constant transformation. On the seafloor, amphipods, Baltic clams and blue mussels filter the water and recycle nutrients, forming the foundation of the food web and supporting the entire community above. Together, these rare and remarkable animals form the true heart of the Baltic Sea, a supporting cast whose survival is inseparable from the fate of the sea itself. Their stories are woven into every wave, every island, and every breath of wind that sweeps across this extraordinary northern world. The Baltic Sea is far more than a static body of water. It is a dynamic crossroads, a vital artery for countless migratory species, and a stage for rare, unexpected visitors. Each year, its shores and waters become a living tapestry, woven with the journeys of animals that depend on its unique environment for survival, rest, and sometimes, by sheer accident, adventure. Among the most iconic travelers is the Atlantic salmon, a species whose life is defined by epic migration. These fish are born in the cool, oxygen-rich freshwater rivers that flow into the Baltic, their tiny bodies perfectly adapted to the gentle currents and stony beds. As juveniles, salmon begin their first great journey, leaving the safety of their natal streams and venturing downstream toward the brackish embrace of the Baltic Sea. Here, they undergo a remarkable transformation, adapting physiologically to the changing salinity. In the open sea, they spend years growing strong, feasting on abundant herring and sprat. The Baltic's unique mix of salt and fresh water provides a challenging yet rewarding environment for these young salmon to mature. When the time comes, an ancient instinct calls them home. guided by the faint chemical signature of their birthplace. They battle upstream, leaping waterfalls and navigating rapids to return to the very rivers where their lives began. Here they spawn, ensuring the next generation will continue this extraordinary cycle, linking the inland waterways to the vastness of the sea. Above the waves, the Baltic skies are transformed each spring and autumn by the passage of millions of migratory birds. Their calls echo across the water, signaling the changing seasons and the relentless drive of migration. For barnacle geese, the Baltic is a lifeline. These birds travel in vast flocks, their black and white forms dotting the wetlands and fields as they pause to feed and regain strength. Their migration is a marvel of timing and endurance. Following the green wave of spring, they track the emergence of fresh grass from their wintering grounds in the Northern Sea through the Baltic's fertile landscapes and onward to the Arctic tundra where they breed. Along the way, islands like Gotland and the lush wetlands of Matsalu Bay become critical oases. Here, the geese feed voraciously, building the fat reserves essential for the final grueling leg of their journey north. Without these stopover sites, the migration of countless birds would falter. The Baltic's mosaic of habitats is indispensable, a network of rest stops in a world where safe havens are increasingly rare. Yet the Baltic's role as a crossroads is not limited to regular travelers. Occasionally, it becomes the stage for astonishing, rare appearances from the open ocean. Young humpback whales, giants of the Atlantic, sometimes stray into the Baltic's shallow, brackish waters. These accidental visitors are a breathtaking sight, their massive forms gliding through unfamiliar territory. But the Baltic is not without peril. The confined waters and dense fishing activity can prove hazardous, as whales risk entanglement in nets, an ordeal that can turn a navigational error into a life-threatening crisis. The presence of these whales, while awe-inspiring, is often a sign of confusion and vulnerability. Their journey into the Baltic is a poignant reminder of the delicate balance between exploration and survival in the animal kingdom. Even more extraordinary are the rare incursions of orcas, apex predators of the world's oceans. Their tall dorsal fins slicing through the Baltic's calm surface are a sight few ever witness. Normally, orcas reign in the North Sea, where they hunt seals and large fish. The Baltic's lower salinity and limited prey make it an unlikely home, yet curiosity or the pursuit of food sometimes draws them in. On rare occasions, a lone orca or a small pod will navigate the narrow Danish straits, likely shadowing schools of herring or tuna as they move between seas. In 2024, a sighting in the Øresund Strait electrified the region as the unmistakable black and white form of an orca appeared in these northern waters, a fleeting but unforgettable encounter. These rare and remarkable visitors, whether salmon on their ancient pilgrimage, geese riding the winds of change, or whales and orcas straying from distant oceans, all underscore the Baltic's role as a living link between worlds. Despite its enclosed nature, the Baltic remains a vital, ever-changing crossroads, where the drama of migration and the wonder of surprise encounters continue to unfold season after season. The Baltic Sea, already a delicate and unique marine environment, faces a barrage of threats that arrive not with warning but with silent persistence. Some newcomers slip in unnoticed, their presence only revealed by the damage they leave behind. These unwelcome invaders, often invisible to the casual observer, can unravel the intricate balance of life beneath the waves. Among the most notorious of these is the warty comb jelly, a translucent predator whose arrival in the Baltic Sea in 2006 marked the beginning of a new ecological challenge. Transported across continents in the ballast water of cargo ships, the comb jelly's journey is a stark reminder of how global trade can inadvertently introduce destructive species into vulnerable habitats. In the Baltic's shadowy, low-oxygen layers, just above the dead zones, the comb jelly flourishes, exploiting conditions that native species struggle to survive in. With an insatiable appetite, it devours vast quantities of zooplankton, critical food for young fish, and even preys directly on fish eggs and larvae, undermining the very foundation of the food web. The consequences of such an invasion are not theoretical. In the 1980s, the Black Sea's fisheries collapsed under the pressure of the same species, leaving behind a devastated ecosystem and empty nets. The comb jelly's success is amplified by a much larger, more insidious force: climate change. As the Baltic warms, the boundaries that once kept invaders at bay are dissolving. Over the past 3 decades, the Baltic surface waters have warmed by 1.44 degrees Celsius, a rapid transformation that is reshaping the entire ecosystem. This warming trend is not just a number, it is a force that alters currents, disrupts seasonal cycles, and challenges the survival of countless species. Winters are now marked by shrinking ice cover, with satellite images revealing record lows that threaten the very existence of ice-dependent life. The Baltic ringed seal, for example, depends on stable ice to breed and raise its young. As the ice vanishes, so too does the future of this remarkable species. Warmer water holds less oxygen, accelerating the spread of dead zones, vast stretches of sea where life struggles to persist, and the cycle of decline feeds on itself. Pollution, both old and new, continues to haunt the Baltic. Plastics drift silently through the water, while invisible chemicals seep into every corner of the ecosystem. Though the use of notorious toxins like DDT and PCBs has been banned, their legacy endures. These chemicals, once heralded as solutions, now linger as persistent threats. Settling into the mud of the seabed, these poisons are not inert. They are slowly absorbed by the smallest creatures, beginning a journey up the food chain. With each step, the toxins become more concentrated, eventually reaching the top predators, creatures that embody the health of the entire sea. Seals and eagles, once symbols of the Baltic's wild strength, now bear the burden of this toxic inheritance, suffering from illness and reproductive failure. Overfishing, too, continues to erode the resilience of the Baltic. Decades of excessive harvests have left fish populations dangerously depleted. Cod, herring, and salmon, once abundant, have been pushed to the brink, their numbers unable to recover even as regulations tighten. The struggle for survival is now visible in every net that comes up nearly empty, a stark indicator of a system under immense strain. The collapse of the eastern Baltic cod population stands as a warning, a signal that the sea's capacity to recover is not limitless. Invasive species, relentless pollution, a warming climate, and the relentless pressure of overfishing have converged to create a perfect storm. The future of the Baltic Sea now hangs in the balance, its fate determined by the choices we make and the threats we choose to confront. Despite the immense challenges, the Baltic Sea's story is evolving, one of resilience, innovation, and the promise of renewal. Across the sea, fleets of research vessels and autonomous monitoring buoys now gather real-time data on water quality, oxygen levels, and nutrient flows, providing scientists with unprecedented insight into the Baltic's complex ecosystem. In state-of-the-art laboratories, teams analyze water samples for microplastics, emerging contaminants, and genetic traces of marine life, allowing for early detection of threats and more targeted conservation strategies. Restoration projects are underway beneath the surface, where seagrass meadows and underwater forests are being revived. These habitats not only absorb excess nutrients but also provide vital shelter for countless marine species. Innovative bioremediation efforts, such as the cultivation of mussel and oyster beds, are helping to naturally filter the water, removing pollutants and creating new nurseries for fish and invertebrates. Satellite technology now tracks the reduction of nutrient runoff from rivers and fields, revealing shrinking dead zones and the gradual return of oxygen-rich waters to once lifeless regions. Along the coast, vast wetland restoration projects are re-establishing natural filters, These wetlands trap sediments and nutrients, buffer against storms, and provide critical stopovers for migratory birds. Cities are investing in next-generation wastewater treatment, using ultraviolet purification and advanced filtration to ensure that only the cleanest water returns to the sea. On land, precision agriculture and sustainable land management are reducing fertilizer use and preventing runoff, protecting the delicate balance of nutrients in the Baltic. As habitats recover, fish populations are beginning to rebound. Cod, herring, and other keystone species are returning to their traditional spawning grounds, signaling the first signs of ecological recovery. Rare aquatic plants and invertebrates are reappearing, their presence a testament to the effectiveness of restoration and the resilience of the Baltic's web of life. The network of marine protected areas continues to expand, safeguarding biodiversity hotspots and critical migratory routes for marine life. With these sanctuaries in place, top predators and sensitive species are making a comeback, their resurgence a powerful indicator of ecosystem health. Cutting-edge genetic research is tracking the recovery of species, ensuring that conservation efforts are guided by the latest science, and that genetic diversity is preserved for future generations. The Baltic's landscapes are adapting to a changing climate, with ongoing research guiding adaptive management to ensure resilience in the face of new environmental pressures. The vision for the future is clear: a Baltic Sea where clean water, healthy habitats, and abundant wildlife are the norm, not the exception. Each wave that breaks on the shore carries the promise of renewal, a testament to what is possible when science, innovation, and determination converge. The Baltic Sea's recovery is not just a hope, it is a process unfolding before our eyes, driven by the tireless work of conservationists and the relentless power of nature itself. The horizon is bright with possibility. With continued commitment, scientific progress, and respect for the natural world, the Baltic Sea can once again become a thriving sanctuary for life, a living symbol of hope restored. Beneath the waves and beyond the reach of even the smallest fish, a hidden world pulses with life, a kingdom invisible to the naked eye, yet fundamental to the Baltic Sea's very existence. Here, billions of microscopic organisms, from phytoplankton to zooplankton, form the living foundation of the entire ecosystem. Phytoplankton, the ocean's green architects, drift in sunlit surface waters. Each cell is a miniature factory, converting sunlight, carbon dioxide, and nutrients into the oxygen we breathe and the energy that sustains all higher life. In the Baltic, unique species of diatoms and dinoflagellates have adapted to the brackish mix of fresh and salt water, thriving where few others can. During spring and autumn, these plankton bloom in vast numbers, coloring the sea in subtle shades of green and gold. Their abundance signals not just renewal, but also the delicate balance of nutrient cycles. Too few and the food web collapses, too many and harmful algal blooms can choke the sea. Floating alongside are zooplankton, tiny crustaceans, larvae, and gelatinous creatures, grazing on phytoplankton and in turn feeding young fish and invertebrates. Copepods, rotifers, and the ghostly larvae of mollusks and worms drift in a perpetual dance, their life cycles timed to the pulse of the seasons. Some, like the transparent mysid shrimp, migrate up and down the water column each day, evading predators while redistributing nutrients across depths. Microscopic bacteria and archaea, often overlooked, orchestrate chemical transformations that keep the Baltic's waters habitable. These microbial engineers break down organic matter, recycle nutrients, and even help detoxify pollutants. In the oxygen-poor depths, specialized bacteria thrive where others cannot, processing sulfur and nitrogen compounds that would otherwise accumulate to deadly levels. Recent advances in genetic sequencing have revealed astonishing diversity among these microbial communities. Scientists now know that each bay, estuary, and open water zone harbors its own unique assembly of plankton and microbes, shaped by salinity, temperature, and nutrient flows. Some species have evolved remarkable adaptations: antifreeze proteins, light-sensitive pigments, or the ability to fix nitrogen from the atmosphere, enabling survival in the Baltic's fluctuating environment. The connections are profound. When phytoplankton bloom, they fuel explosive growth up the food chain, but also trigger a cascade of microbial activity that determines whether nutrients are recycled or lost to the depths. The ebb and flow of these microscopic populations influence everything from fish stocks to the chemistry of the water itself. By studying this hidden kingdom, researchers are unlocking new insights into the resilience and vulnerability of the Baltic Sea. The fate of its vast and visible life depends, ultimately, on the health of these unseen multitudes. Every drop of water is a universe, teeming with organisms that, though invisible, hold the key to the sea's future. This is the engine of the Baltic, a living, breathing world at a scale too small to see, yet powerful enough to shape the destiny of an entire sea. Long before the first living cell drifted through its waters, the Baltic Sea's story was written in stone and ice. Its basin is a product of epic geological forces, slow, patient, and relentless. Millions of years ago, this region was a patchwork of ancient bedrock and deep valleys shaped by continental collisions and the restless movements of tectonic plates. During the most recent ice age, colossal glaciers blanketed the land, grinding mountains to dust and carving out vast depressions beneath their frozen weight. As the climate warmed, these glaciers melted, flooding the newly formed basins with torrents of fresh water. The land, freed from its icy burden, began to rise, a process known as isostatic rebound, creating a landscape in constant transition. Beneath the waves, the Baltic Sea's floor is a mosaic of underwater features. Shallow banks and submerged ridges bear the scars of glacial scouring, while deep troughs, like the Landsort Deep, plunging over 450 meters, act as cold, dark reservoirs for dense, oxygen-poor water. These trenches are remnants of glacial rivers and ancient meltwater channels, now hidden beneath layers of silt and clay. Along the coastlines, drowned river valleys, fjords and flayeds, form intricate networks of inlets and lagoons, each with its own microclimate and ecological character. Here, submerged boulders and rocky reefs provide shelter for marine life, while shifting sandbanks and mudflats are constantly reshaped by wind and current. The seafloor is far from static. Seasonal storms and powerful currents move sediments, build new sandbars, and expose relics of the past, fossilized remains, sunken forests, and even the occasional Stone Age artifact. In some areas, methane seeps bubble up from ancient organic deposits, hinting at chemical processes deep beneath the surface. The Baltic's unique brackish character is also written in its geology. Subterranean springs and saltwater inflows from the North Sea mix with fresh water from hundreds of rivers, creating ever-changing gradients of salinity and temperature. This dynamic environment shapes not only the chemistry of the water, but the very contours of the seafloor itself. In this underwater world, time moves at a different pace. Each layer of sediment is a chapter in the Baltic's history, a silent record of floods, droughts, and the slow dance of continents. Today, scientists use sonar mapping, sediment cores, and remote-operated vehicles to explore these hidden landscapes, revealing a world as dramatic and varied as any above the surface. The geological past of the Baltic Sea is inseparable from its present. Its shifting depths and ancient formations continue to influence currents, habitats, and the very life cycles of the organisms that call this sea home. Beneath the waves, the legacy of ice and stone endures, shaping a world that is both ancient and ever new. The Baltic Sea is a place of perpetual transformation, never more so than in the rhythmic turning of the seasons. With each passing month, the entire ecosystem pulses to the subtle choreography of light, temperature, and shifting winds. Spring arrives as a silent revolution beneath the surface. As sunlight returns and the ice recedes, a surge of fresh water from melting snow and swollen rivers pours into the sea. This influx stirs the upper layers, infusing them with nutrients accumulated over the winter's stillness. Phytoplankton, the microscopic architects of the food web, awaken in vast blooms that tint the water green and turquoise. These blooms are fleeting yet vital, feeding zooplankton swarms and, in turn, the herring, sprat, and the countless larvae that depend on this seasonal bounty for survival. Summer brings warmth, but also complexity. The sun's rays heat the surface, creating a sharp boundary, a thermocline, that separates the upper, oxygen-rich waters from the colder, darker depths. In the shallows, seagrass meadows and algal forests reach their peak, sheltering juvenile fish and providing hunting grounds for seals and seabirds. But deeper down, oxygen dwindles, and the infamous dead zones begin to expand, a silent reminder of the delicate balance at play. Autumn's arrival signals a time of mixing. Powerful winds churn the sea, breaking down the layers that summer built. Nutrients are redistributed, and a second, smaller plankton bloom briefly rekindles life before the darkness returns. Migratory birds gather in vast flocks, feeding voraciously in coastal lagoons before embarking on their journeys south. Shoals of fish move to deeper waters, seeking refuge from dropping temperatures. Winter is a season of quiet endurance. Ice creeps across bays and archipelagos, locking the surface in crystalline silence. Below, life slows, but never stops. Some species enter a state of suspended animation, while others, like the hardy Baltic cod, continue their slow patrols through the cold, oxygen-starved depths. The ice itself becomes a platform for eagles and otters, while beneath, brine channels form hidden passageways for microscopic life. Each season brings both opportunity and challenge. The timing of blooms, migrations, and breeding cycles is finely tuned to the Baltic's unique rhythm. A rhythm now threatened by climate change, which brings warmer winters, altered currents, and unpredictable weather patterns. The sea's pulse is changing, and with it the fate of countless species. Yet the Baltic endures, adapting as it always has. Its living tapestry is woven from cycles of abundance and scarcity, of calm and storm. In every shift of season, the sea reveals its astonishing resilience, a world in motion, forever shaped by the turning of the year. Beneath the surface of the Baltic Sea, invisible forces carve the boundaries of life. Here, currents and water chemistry are the silent architects, shaping every habitat, migration, and survival strategy. Unlike vast oceans, the Baltic's currents are a complex interplay of wind, tides, and freshwater inflows. Rivers pour in from the north and east, their waters lighter and less saline than the denser, saltier currents that creep in from the North Sea. The two rarely mix completely. Instead, they form a layered structure, fresh water riding above, salt water below, divided by a sharp halocline. This boundary limits the exchange of oxygen and nutrients between the layers, influencing where life can thrive. The chemistry of the Baltic is equally distinctive. Its brackish water, neither truly fresh nor marine, sets unique physiological challenges. Many species here are living at the very edge of their tolerance, their cells constantly working to regulate salt and water balance. For some, like the blue mussel and Baltic herring, this means slower growth and smaller size than their oceanic relatives, an evolutionary trade-off for survival in a diluted sea. Currents also act as silent couriers. They carry nutrients from land to sea, fueling explosive plankton blooms in spring. Yet these same flows can transport pollutants and excess fertilizers, feeding the growth of harmful algae and expanding the notorious dead zones where oxygen vanishes from the depths. In the narrow Danish Straits, a delicate exchange takes place. Here, pulses of salty North Sea water squeeze into the Baltic, replenishing the lower layers with vital oxygen. These rare inflows can revive struggling ecosystems, if only for a time. The frequency and strength of these events are changing, driven by shifting winds and a warming climate, with profound consequences for the sea's future chemistry and the creatures that depend on it. Even the sea's subtle currents sculpt its underwater landscapes. Along the coasts, wave-driven flows shape sandbanks and lagoons, dynamic habitats for spawning fish and nesting birds. In deeper regions, sluggish bottom currents slowly transport sediments, burying organic matter and shaping the contours of the seabed. In the Baltic, nothing is static. Every chemical shift, every swirling eddy sets off a chain reaction across the food web. The sea's identity is not fixed, but forged anew each day by the restless movement of water and the ever-changing balance of salt, oxygen, and life itself. Here the true architects remain unseen, but their influence is everywhere, quietly scripting the story of the Baltic Sea. As the sun rises on the Baltic's horizon, the future of this unique sea is poised on a delicate edge. The challenges facing the Baltic are as complex as its waters, a convergence of climate change, pollution, invasive species, and shifting human demands. Each force, invisible yet powerful, is reshaping the fate of the sea and those who depend on it. Warming temperatures are altering the Baltic's very chemistry. Ice cover retreats earlier each year, while surface waters grow warmer and less oxygenated. These changes ripple through the ecosystem, favoring some species while pushing others to the brink. Harmful algal blooms, already a recurring threat, may become more frequent and intense, fueled by warmer waters and excess nutrients from agriculture and urban runoff. Sea levels are rising, pressing saltier waters further inland and threatening delicate coastal habitats. Wetlands and spawning grounds, lifelines for fish and birds, are at risk of being swallowed or transformed. Meanwhile, the frequency of extreme weather events increases, challenging the resilience of both natural habitats and human infrastructure. Yet, amid these looming threats, the Baltic Sea also stands at the frontier of innovation and hope. International cooperation among bordering nations has led to ambitious agreements to reduce nutrient pollution and restore vital habitats. New technologies, from precision agriculture to advanced wastewater treatment, offer real promise to curb the flow of contaminants into the sea. In the depths, scientific monitoring and data-driven management are guiding efforts to revive oxygen-starved zones. Artificial oxygenation projects and habitat restoration experiments are underway, testing the limits of what is possible. Meanwhile, marine protected areas are expanding, offering safe havens for vulnerable species and helping to rebuild populations from the ground up. The future of the Baltic will not be written by nature alone. It will be shaped by choices, by the balance struck between development and conservation, by the effectiveness of cross-border collaboration, and by the willingness to innovate in the face of uncertainty. In this sea of shifting boundaries, the only constant is change. The Baltic story is still being written, and with vigilance, ingenuity, and collective resolve, its next chapter could be one of renewal and resilience, a testament to the power of nature and human stewardship working together.